Hello there, Mr. Sutton here with the AB Calculus 5-2 Extra Practice number 3 solutions on Antiderivatives Part 2. To take the antiderivative on this one, it helps if we first know that the antiderivative of negative cosecant squared of something is going to be cotan of the something with maybe a few modifications. So I'm going to start by writing cotan of x over 27. But now since we have this inner linear function, we have to divide by the derivative of this to offset the chain rule. So we're going to really be doing dividing by 1/27th, which is really multiplying by 27. We already have a 3 out there. Remember, the negative was already kind of included in the fact that this is positive cotan. So it's 3 times 27 outside, giving us 81. And then we have a plus c. For the antiderivative on this one, I'm going to start with the antiderivative of e to the 6x. Which is going to be e to the 6x with some modifications, but let's start there. Now, because I have a 6x rather than just an x in there, I'm going to have to divide by the derivative of this inner linear function just to offset the chain rule. So I'm going to have a negative 2 divided by the 6 from there, which ends up giving me negative 1/3 out in front, and then I have that plus c that I always have. On this problem, taking the antiderivative, this is actually a 1 over x kind of situation. So for my antiderivative, I'm going to start by writing ln absolute value of 7x, just like ln absolute value of x. Only because this is 7x rather than x, I'm going to have to divide by the derivative of 7x just to offset the chain rule. So I've got a negative 3 outside already as a coefficient. Now I'm going to divide that by 7 to get negative 3 over 7. And then I have that plus c. To make my life a little bit easier on this antiderivative, I'm going to do some trig simplification. So the key on this one is to split this up into 2 fractions. In one fraction, I'm going to have a negative 1 over sine of x, so I'm splitting up this sine of x here. In the other fraction, I've got a cosine of x over sine of x, and I'm splitting it up with multiplication. So now I can simplify this using those reciprocal trig functions. This first one is really just negative cosecant of x, and this next one, cosine over sine, we know that to be cotan of x, and the dx is still hanging around. So antiderivative of negative cosecant of x, cotan of x, that one is just directly going to be cosecant of x plus c. Before trying to take the antiderivative of this, I'm going to do a little trig simplifying. So I know that cosecant is the reciprocal of sine, so I can rewrite this as negative 4 cosecant squared of x, and now I don't have to deal with that fraction anymore. Antiderivative of negative cosecant squared of x is going to be cotan of x. This 4 is along for the ride, so we've got 4 cotan of x plus c. To take the antiderivative on this one, it helps if you recognize that this is kind of like having a 1 over 1 plus x squared sort of situation. Not quite, but we're almost there. So eventually I'm going to try to use arctan to take the antiderivative here. But first I need to write this as 1 plus something squared. So to do that, I need to factor 100 out of the denominator, leaving me with 1 plus 1 over 100 x squared. And my next step, I'm going to do a couple things. For one thing, I'm going to pull this 1 over 100 outside the antiderivative symbol, outside the integral. Inside now, I'm going to rewrite this 1 over 100 x squared term as 1 over 10x, and then square both of those things like so. The reason I'm doing this is because now I have a 1 plus something squared sort of pattern, which is what arctan needs to use it for the antiderivative. So now I am going to turn this into basically arctan of 1/10 of x. Only I have to think about the coefficient now. So I already have a 1 over 100 coefficient out here. Since I'm taking the antiderivative of something with a linear inner function, I have to divide by the inner derivative. So I'm dividing by 1 over 10, which means multiplying by 10. 10 times 1 over 100 is just 10 over 100, which I can reduce finally to 1/10. And then don't forget your plus c. To take the antiderivative on this one, the easiest way to do it is to just distribute this 6x and use the reverse power rule. So we're going to have negative 12x to the 5th plus 6x. And now going left to right here, this first exponent bumps up to a 6. Dividing by that, we have negative 2x to the 6th. And then this next exponent's going to be a 2. Dividing by that, we have plus 3x squared. and then plus c. For this problem, it's critical to notice that the stuff inside this square root is actually a perfect square trinomial. If you try factoring it, maybe you didn't notice it first, but if you try factoring it, things that multiply to 49 and add up to 14, well, yeah, plus 7 and plus 7. So this is really x plus 7 squared. And that's important because you're squaring inside a square root, so those are going to cancel out. This is then really just 1 over x plus 7. Well, this is a 1 over x kind of situation, so antiderivative of this is going to be ln absolute value of this stuff. And we have to think about, if I have something with a derivative that isn't just 1, I'll have to divide by that inner derivative, at least if it's a linear function. But here, if you just take the derivative of ln of x plus 7, you do end up with 1 over x plus 7. So we don't need to do anything fancy with the coefficient. We can just stick a plus c on it and call it a day. For this antiderivative, the trick is to divide everything by this x to the 4th in the very beginning. So this is going to be 4x to the negative 3 minus 15x to the negative 4. And now that we've done that, we can just use our reverse power rule on both of these. So this first exponent is bumping up to a negative 2. Dividing by that, we have negative 2x to the negative 2. And over here, this exponent bumps up to a negative 3, leaving us with positive 5x to the negative 3. And then we have a plus c. For this antiderivative, in general, the antiderivative of sine of x is going to be negative cosine of x, but there's already a negative out in front. So I'm just going to start by writing this as positive cosine of 3x. But then I have to divide by this inner tail here because it's not just x, and it's linear. So that's going to end up being 5 over 3 out in front, and then we have our plus c. On this antiderivative, in general, the antiderivative of secant of x tan of x is secant of x. So I'll start by writing secant of 5x minus 4, because I'm pretty sure I'm going to need to take the derivative of something with this in it to get this expression up here. But because I have a 5x minus 4 in here, a linear function whose derivative is not 1, I have to divide by the derivative of that. So divide by 5 to offset the chain rule. So I already had a 2 out in front. I'm going to end up with a 2 over 5 then, times all that. And then I have our plus c. To take the antiderivative on this problem, I'm going to start by factoring a negative out of all of this stuff. So take a negative 1 out of the denominator, leaving me with a negative outside the integral, and inside we have a 1 over x squared minus 4x plus 5. All right, so why did I do that? Well, at some point I want to factor this, but I'm not quite ready to factor it. If you look at this right now, it's not quite factorable, and there's nothing to cancel anyway, so factoring wouldn't help us in that respect. But what we are going to do here, and this is where it helps if you look at the answer choices, you'll notice that 3 of these answer choices have arctan or tan inverse in them. So if we could maybe get this denominator in a format that arctan likes, something with a 1 plus something squared, we might be able to actually match it with one of these answer choices. Well, we're almost there. If you take a close look here, we've got x squared minus 4x plus 5. This is only 1 away from being a perfect square. If we split up this 5 into a 4 plus 1, which totally legal, right? I'm just unadding these things. I could always add them back together to get 5 if I wanted to. If we do this split, then these first 3 terms are actually a perfect square trinomial. I can factor these first 3 terms. 2 things that multiply to 4 and add up to negative 4, well, that would be x minus 2 and x minus 2, or x minus 2 squared. And now we have something squared plus 1, which we can use with our arctan antiderivative. So I'm just going to write this as negative arctan of x minus 2 now, plus c. And if you just take the derivative real quick, you'll end up with this expression right here. So that's going to end up being answer choice. We need a negative out in front, a negative inside, answer choice B. On this problem, I'm trying to take the antiderivative of this expression. Now, this is a big, confusing looking mess if you didn't have any multiple choice answers to help you. But if you look at some of these, we have an arctan here. We have these 2 arc signs. So if you think about why they might put those in the answer choices, we have a square root of something with an x squared in it. If I could maybe get this to be like a square root of 1 minus something squared, there's a chance I might be able to match one of these arcsine functions. The rest of these, if you take the derivatives, look nothing like this. So we're gonna try for this arcsine approach. In order to get 1 minus something squared in here, though, I first need a 1 inside this square root. And I can't just throw a 1 in there for free. I have to pay for it, right? So if I'm going to add a 1 in here, at the same time I have to subtract a 1 so that I'm not actually changing the value. But what I am doing is allowing myself to rearrange and rewrite things a little bit. So I'm going to factor a negative 1 out of these last 3 terms in here. That's going to leave me with 1 minus parentheses, positive x squared plus 2x, and also plus 1. Now the reason this is very significant, if you look at this, this is actually a perfect square trinomial. Two things that multiply to 1 and add up to 2, well, this is just x plus 1 times x plus 1, or x plus 1 squared. So we see here that we actually do have the square root of 1 minus something squared. So we can use arcsine for our antiderivative. This is then going to end up being 2 arcsine of x plus 1 plus c. So that's going to end up being answer choice C.